We use computers daily, but what actually makes them so powerful? What enables them to handle so many tasks? Let's explore what defines a computer and how it works. What exactly is a computer, and what sets it apart from other machines? Programmable device. A computer processes data based on programs, taking input and producing useful output through a series of instructions. More than numbers. While early computers handled mostly numerical calculations, modern ones manage everything from videos to web browsing, thanks to powerful processing. The term computer, comes from the Latin computare, which means to calculate. Today, they are used for far more than calculations. Hardware and software. A computer's physical components, the hardware, work in harmony with instructions and programs, the software, to perform tasks and deliver results. The CPU. How does a computer manage to process vast amounts of information so quickly? The CPU is the brain. The CPU, central processing unit, is the core of the computer that processes commands and manages tasks, working as the brain behind every operation. Clock speed. CPU speed is determined by its clock speed, which refers to how many instructions it can handle per second. Faster clock speed means better performance. Multiple cores. Modern CPUs feature multiple cores, enabling them to process multiple tasks at once, boosting efficiency in multitasking environments. Cache memory. The CPU's cache stores frequently accessed data, speeding up tasks by reducing the time it takes to retrieve information from the main memory. Memory and storage. How do computers store and recall both short-term and long-term information? RAM, random access memory, is where active tasks are stored, allowing the CPU to access them quickly. More RAM means smoother multitasking. Storage, HDD and SSD, long-term storage, found in hard disk drives, HDD, or faster solid-state drives, SSD, holds data, applications, and files even when the computer is off. RAM versus storage. RAM holds temporary data for immediate tasks, while storage is used to keep data permanently until it's needed again. Virtual memory. When a computer runs out of RAM, it can use part of its storage as virtual memory to keep functioning, though at a slower pace. How does a computer work? What happens inside a computer when we press a key or click a button? Input, processing, and output. Computers receive input, process that information, and then provide an output, whether that's displaying text or running an app. The fetch, decode, execute cycle. The CPU continuously fetches instructions from memory, decodes them, and executes them at lightning speed. Binary code. Computers process everything using binary code, zeros and ones, that represent all forms of data, from documents to images. Parallel processing. With multiple cores, computers can process several tasks at once, making them more efficient and capable of handling heavy loads. Hardware. How do we interact with a computer? How do we give commands to computers, and how do they communicate back to us? Input devices. Devices like keyboards, mouse, and touchscreens allow users to send commands and data to the computer for processing. Output devices. Once a computer processes data, output devices like monitors, printers, and speakers display or present the results. Peripheral devices. External devices, such as webcams and game controllers, enhance the functionality of computers by providing additional ways to interact with them. Modern interaction. Today we interact with computers in more intuitive ways, using voice commands, touch gestures, and even virtual reality to make communication smoother. Software. What makes a computer useful? How does software bring a computer to life, and why is it so important? Software defined. Software refers to the instructions that tell the hardware what to do, whether it's system software like operating systems or application software like games or browsers. Types of software. System software manages the hardware, while application software helps users perform tasks, from writing documents to editing photos. Software-hardware interaction. Software gives instructions to the CPU, which directs the hardware to perform specific tasks, like opening an app or playing a video. The need for updates. Software updates keep computers running efficiently, improving performance, fixing bugs, and addressing security vulnerabilities. Conclusion. Why is understanding computers so important? Why is it essential to understand how computers work, especially in today's tech-driven world? Empowerment. Knowing how computers function enables you to troubleshoot, optimize performance, and use technology more effectively in both personal and professional settings. Tech skills. For aspiring developers, IT specialists, or hackers, understanding the basics of hardware and software is a critical step in mastering programming, security, or system design. Innovation foundation. This knowledge builds a strong foundation for learning advanced technologies, developing better applications, and identifying system improvements. Security awareness. It helps you protect your data and understand how to secure systems, an essential skill in today's increasingly digital and interconnected world. Thanks for watching. If you found this video helpful, please don't forget to give it a thumbs up and subscribe for more content like this.